Hello and welcome to a new episode of Learning from the Mistakes of Others. In my previous video, Thank You Conspiracy Theorists, I showed that it is easy learning new things every day by just looking at the mistakes conspiracy theorists make. A common mistake is that they think there's a connection between the effort you have to put in recreating an image to it actually being a valid recording of reality. Is there a connection? Best example is to take a frontal photo of a white wall. This is something you can easily create in Photoshop. Yet one is a picture of the real world, the other one is not. So what is the problem with planets? Why are there people who think that images taken on partly international missions are created artificially? Probably because they are confusing planets with objects in their environment. Also, they don't think about what makes images look realistic. As you see, they cannot tell what the image is supposed to look like instead. When beginning to learn how to produce realistic images, you will also learn what to avoid. And what are the image features that make something look realistic? So let's go the other way. Let's take a fairly realistic fake image and see if these image features also should apply to planets. I know 3D artists will find a lot of things to improve even on that image here, but for our purposes it will be sufficient. Producing artificial 3D images is normally done via ray tracing. Put simply, to know the color of a pixel on screen, you have to trace the virtual ray in the virtual scene back to its origin. That works fine, but the real world is more complicated than that. As the point you end up also has a different color because it is hit by an uncountable number of light rays emitted by other surfaces. The real world is a complicated mess of light rays heading in all directions. There is an attempt to simulate this, it's called global illumination. This technique takes a lot of time to render and a lot of things happen automatically. For example, shadows and corners being slightly darker, caustics with transparent objects, and light spilling from one surface to another. The color from the wall spills over to the spheres. It's hardly visible, but if you turn it off and use several white light sources to simulate light rays coming from all different directions, the image becomes less realistic. So does global illumination apply to planets? Not really. There are no surfaces nearby that could cast light rays. The stars are too faint for a light source, and the sun, due to its distance, only casts simple parallel light rays that go on to infinity when reflected by the planet. So let's just turn off global illumination for our scene. Real objects around us also have a visible surface structure. Techniques for recreating this in an artificial image without the need for an overly complicated virtual object are, for example, normal mapping or bump mapping, where a surface gets a structure based on separate texture images. Do planets have a visible surface structure? Only when they are small. Moons and asteroids also have one. As gravity makes things rounder and rounder if they increase in mass. Take Earth. It has a diameter of about 13,000 kilometers and the highest elevation is only 8 kilometers. That is about as smooth as a billiard ball. Even worse with gas giants, like Jupiter or Saturn. They don't even have a solid surface. This is perfectly smooth from a certain distance. So let's also turn off surface structure in our scene. Also, objects all around us have a thickness. Even if you have a sheet of paper, it has a volume. But if we look at the rings of Saturn, they don't seem to have any. Let's do the calculation again. Saturn has a diameter of over 116,000 kilometers. But the rings consist of countless microscopic particles up to the size of sand grains or even boulders the size of a house. The thickness of these rings is about 1 kilometer. The viewing distance here is about 2 million kilometers, so it is virtually impossible to see any thickness. This is a sheet sharper than a razor blade if the planet was the size of a ball. So now let's turn off any thickness in our scene. Next, let's talk about the environment. There should be any. Things look realistic if they cast shadows or are comparable to other objects around it. None of that with planets. As we discussed in previous episodes, something is probably a real image if there are not even stars visible in the background. If you have any surface hit by the sun in the image, it is nearly impossible to have visible stars in the background at the same time. One of the best ways to find out if a space image is real. If you have the sunny side of a planet and stars in the background, then it's probably a scene out of a blockbuster movie. So let's turn off the background in our scene. Okay, that looks quite fake already. Now we apply some textures and we got a nice Saturn. So yes, conspiracy theorists are right in one thing. It looks fake. But the reason is that they confuse a planet with a basketball in their garage, disregarding what they might think what the planet should look like. This is the real world. And there are reasons why things look like they do. Let's take the quote of Elon Musk. You can tell it's real because it looks so fake. That's partly correct. While something looking fake is no indicator of being real, nature is in no way obliged to look like you would prefer. Maybe he understood what you perceive as realistic is shaped by the environment you live in. Go beyond that and you will see things that don't match the world in your head. Only if you are in a space station in orbit of Earth or maybe in orbit around Saturn in the future, the world in your head will grow. Until then, you will just have to learn why things look like they do. I'm on 1415 and the real world is incredible.